Imagine a future where humans don't just visit the moon, but live there permanently. How do we make that possible? From growing our own food in lunar soil to recycling every drop of water, we're diving deep into the mind-bending engineering challenges and revolutionary technologies needed to build humanity's first self-sustaining home on another world. The moon, our rocky companion in space, has always been a source of wonder and a target for human ambition. But before we lay down roots on its surface, we need to understand and conquer the harsh realities that await us. The moon offers no refuge from cosmic radiation. Its surface is a vacuum and its temperature swings between extreme highs and lows. Can our technology really shield us from these conditions? And if so, how much will it cost? Current space station tech is great, but it's designed for low Earth orbit. It's not a simple copy-paste solution for the lunar surface. Let's start by talking about the biggest threat to human survival on the moon: radiation. Space is a dangerous place if you're not protected. The moon doesn't have a magnetic field or a substantial atmosphere like Earth does to deflect cosmic rays and solar winds. This means that on the lunar surface, astronauts would face significantly higher levels of radiation than they do here at home. Exposure to this much radiation can lead to acute radiation sickness within hours or even minutes, causing nausea, vomiting, fatigue, and a weakened immune system. Long-term exposure can increase the risk of cancer and other health problems. So how do we solve this problem? We need shielding. But when it comes to protecting astronauts from deadly radiation on the moon, we can't just slap on any old shielding material. We need something that's lightweight yet super effective at filtering out those harmful cosmic rays. One potential solution is to use water as a radiation shield. Water is actually pretty good at absorbing radiation, making it a decent option for protecting astronauts. Plus, it's already a vital resource for human survival, which is important for long-duration missions. Another option is to use regolith, the dusty material covering the moon's surface. Regolith is rich in minerals like silicon dioxide, aluminum oxide, and calcium oxide, which can help shield against radiation. Plus, it's already available on site, so we don't have to transport it from Earth. But regolith also presents some challenges, including its abrasive texture, which can damage equipment over time, and its loose consistency, which could pose stability issues for buildings and other structures. Still, researchers are constantly exploring ways to make regolith more usable for construction and radiation shielding, thanks to its abundance on the moon. Regolith could end up being an essential resource for building self-sustaining habitats there. But radiation is only one piece of the puzzle. The vacuum of space poses its own unique set of challenges. Without an atmosphere, there's no air to breathe, and no pressure to keep fluids in our bodies from boiling. And let's not forget about those extreme temperature swings. On the moon, daytime temperatures can soar to 127 degrees Celsius, while nighttime temperatures can plummet to minus 173 degrees Celsius. That's a swing of almost 300 degrees. So how do we shield against the vacuum and extreme temperatures of space? One promising approach is using inflatable modules made from multi-layer insulation, similar to what is used in modern space capsules. These modules can provide a pressurized environment for astronauts to live and work in, while taking up less space during launch. As for temperature control, active cooling systems could help regulate the temperature inside the habitats, while passive systems like thermal mass and insulation can help maintain a more consistent internal environment. Another crucial factor for a self-sustaining presence on the moon is frequent resupply missions. But here's the catch. We're aiming for truly self-sustaining. So relying on regular shipments from Earth just won't cut it. Instead, we need to design a habitat that can support itself, producing all the resources necessary for long-term habitation without needing to import anything from the outside. Now, it might be tempting to think of a lunar colony as a straightforward extension of life on Earth, just with some extra precautions for safety. But the truth is, to survive and thrive on the moon, we'll need more than just engineering know-how. we'll have to completely reimagine how we live, work, and sustain ourselves. We're going to need closed-loop systems to recycle our air, water, and waste. The International Space Station has begun to adopt some of these systems, such as recycling water and urine back into drinkable water. But a lunar habitat will need to go further, possibly using plants to filter the air and generate oxygen. This is where biology meets engineering, not just machines that sustain life, but actual living things thriving in a balanced ecosystem. That's the idea behind closed ecological systems like the Biosis project, which uses plants and microbes to simulate a self-sustaining biosphere. By carefully selecting the right organisms and monitoring their interactions, we can create a system that cleans the air we breathe, provides us with fresh food, and recycles our waste, all while adapting to the unique challenges of life on the moon. Next, we need lunar agriculture. Growing food on the moon will be crucial for long-term sustainability, and luckily, we have some tricks up our sleeves. One approach is growing plants directly in lunar regolith after treating it to remove harmful elements. Another option is using hydroponics, which grows plants in nutrient-rich water instead of soil. Hydroponic gardens are already a thing on Earth, and they can offer a controlled environment for growing fresh produce in space. Regardless of the method, we'll need to optimize light and nutrients to mimic an Earth-like environment for plants to flourish. Now, powering our lunar home is another big challenge. We're looking at next-gen nuclear fission reactors that could provide the reliable, high-output energy we need for life on the moon. Although fission has its drawbacks, it's a relatively safe and efficient way to generate large amounts of electricity. For example, NASA's Kilo Power Reactor is a small modular fission reactor that could potentially provide enough power for a lunar base. The reactor is designed to be durable, reliable, and able to operate for years without refueling, making it ideal for use in remote locations like the moon. Additionally, NASA has plans to develop the Artemis Base Camp, a potential outpost on the moon that would serve as a hub for future missions and could possibly be powered by kilopower or a similar reactor. Solar power is another option, but we'll need advanced energy storage solutions to compensate for the moon's lack of sunlight during its 2 weeks of night. We'd also want to locate our solar panels strategically on the moon's equator to maximize sunlight exposure. All these power sources will be vital for keeping our lights on and our life support systems running smoothly. Resource utilization and manufacturing are the next step. ISRU stands for In Situ Resource Utilization, basically using what's already on the moon to support our activities there. For instance, we can extract water ice, oxygen, and other building materials from regolith. That way, we're not totally reliant on transporting everything from Earth. We've already got some pretty cool tech like the MXT water extraction system developed by Astrobotic, which uses a combination of heat and vacuum pressure to extract water from regolith, and the European Space Agency's Moondust Regolith Simulant, which provides a realistic representation of lunar soil for testing purposes. These are the stepping stones for setting up ISRU on the moon. 3D printing is another game changer. We can use lunar materials like regolith and ice to create habitats and tools on site, reducing our dependence on importing everything from Earth. And the best part, we've already started to see some impressive results. The European Space Agency's 3D printed Mars Dune habitat, for example, demonstrates the potential for creating structures using local materials. It's designed to be strong, sustainable, and expandable, making it a promising concept for future exploration missions. And finally, let's talk about designing a life worth living on the moon. After all, we're not just trying to survive, we want to thrive. A big part of that is addressing the psychological well-being of people living on the moon. We need to create comfortable, stimulating environments that foster a sense of community and purpose. One approach involves creating social structures that encourage collaboration and communication, as well as providing opportunities for leisure and relaxation. We could also design physical environments that mimic the natural beauty of Earth. such as parks, gardens, and even virtual reality simulations of our favorite places. Medical facilities and emergency preparedness are equally vital for a lunar colony. Living on the moon will come with unique risks and challenges, and we need to be prepared for everything from minor injuries to major emergencies. Telemedicine and robotics can play a crucial role here, allowing us to consult with experts on Earth when necessary and providing remote assistance in emergencies. We'll also need to develop protocols for dealing with everything from radiation exposure to psychological distress. Ultimately, our long-term vision for the moon should extend beyond just survival and basic comfort. The moon could become a hub for research and tourism, offering a unique vantage point for observing the universe and a thrilling destination for space enthusiasts. But all these aspirations depend on our ability to engineer a self-sustaining lunar habitat, a place where humans can live, work, and thrive while exploring the vast potential of our solar system. If you want to learn more about the incredible feats of engineering that are shaping our world and our future among the stars, like and subscribe for more updates. As always, thank you for watching and keep looking up.